Today we're going to talk about scientific papers with an example of something that is not a scientific paper, so that we can see, using a negative example, what we're looking for. So the purposes of my project course is to create something that's like a scientific paper, to go about a process that is very much like science. And this time we're going to make some measurements on how fast caffeine is released by tea. But first of all, we need to work out where we're going to place it, what we're going to do with this paper. Even if we don't actually write it, we want to know what are we going to do with it. So first of all, we need to know what a scientific paper is. And a good place to start there is what a scientific paper is not. Okay, so this is a paper in apparently in this place called up here, homeopathy.com, Homeopathy's papers, patients treated by homeopathic physicians and Italian descriptive study. So here is the paper on ResearchGate, and what we can see is no evidence that it's been published anywhere other than on ResearchGate. Maybe that weird homeopathy site. You can normally see when papers are published on ResearchGate that there's a link to the original study up here. That's because ResearchGate is not actually a journal, it's a database where you can upload whatever you want. It's not peer reviewed, it's just a place to put things. So if I wrote a paper about my science, I might put it there as a copy. So here is evidence of what I was trying to say. So they are claiming that they used ResearchGate for rapid publication and dissemination of their contributions, somewhere in this box here. The platform is a network of over 16 million researchers from around the world, etc. So peer review, very much like democracy, is a system that kind of works, that everybody can see that there are a lot of problems with, but that we don't have a better alternative for. So if we send our paper for peer review, it gets sent to an editor whose job it is to check to see if it has sufficient quality to be in that particular journal and be the right style. And then it goes to reviewers, typically 2, maybe up to 4, who will then have a look at it. They will be other scientists who should be able to understand the content. Those scientists have the job of looking through to see that it's rigorous and to see that the scientists, the people who have made the paper, who've written it, have not made any obvious mistakes. And they also are there to see that they're not doing anything untoward. So all of the standard things that happens when people are involved, prejudices. So if for example, a paper comes from Africa, for example, it may or may not be treated differently to a paper that comes from America. Likewise, if it comes from a top university, such as Princeton, for example, it may be treated differently to a paper that comes from a not so good university or a not so well-known university. Money is, of course, also an issue. So there are 2 types of journals: open access journals and old-style journals. Old-style journals make their money from subscribers paying to read them, and open access journals make their money from writers paying to put their material into them. So an open access journal anybody can look at, it's free to look at, but it's not free to put your paper into it. And a normal standard journal, you would, or let's call it old style journal, is free to put your things into, but you have to pay to read it. This means that the journal is obviously slightly affected by how it gets its money. So if it gets its money from high level institutions paying it lots of money, it was motivated to have very good papers and not very many of them. If it's a journal that goes to a lot of people, it's motivated to have a lot of papers in it. If it's open access, it is more likely to take a paper regardless of the quality because it is paid for. Even in a traditional journal, the same thing is true. So if you want your article to be featured or to have a picture in it or to have color pictures in it, you have to pay. In the past, it's quite a long time ago now, but in the past, color images in books cost a lot of money, and that's kind of carried forward. So it costs of the order of €1,000 or dollars or pounds to get images into a journal in color. And if you take the same paper and put it into a journal and offer to pay for color images, it's more likely to get in than if you don't, because obviously the journal makes more money from you, or some money at all. Obviously that doesn't happen all the time, but it's a standard problem. And when people are involved, people do people things, people are easily distracted, and the same bad things happen just as they always do in absolutely everything. But if we don't have peer review, then it goes straight to, in the case of ResearchGate, it goes straight onto the internet and anybody can look at it and it appears to be a publication. If we send it to a more journalistic publication, so if we send it to a normal newspaper, then it will be checked for its journalistic integrity and not for its scientific integrity, unless they have a proper science writer. In the case of an article in a newspaper, it should be checked. But looking at America, looking at the UK, the whole issue of fake news is a problem with the newspapers not controlling their information properly, and also a problem with the internet providing us with lots and lots of information that is not very well checked. And then we can't be sure what is right and what is not right. After peer review, however, the process is not over. So what happens after peer review? The paper goes in, assuming it's accepted, the paper goes into the journal, it's typeset and sent in, and it then gets published. It gets published online first, and it gets published in print, although that doesn't matter so much these days because pretty much everybody looks at everything online. And once it's there, other people can look at it, and the whole point of a scientific paper is that other people can copy what has been done and try to prove that it is either correct, try to agree with it, or try to prove that it is incorrect. So assuming we publish our caffeine study, other people can do exactly the same measurements because we are required to say exactly how we did it. So they make the same measurements, and they will either agree with us or they won't. And then they can say, yeah, agreeing with those people on their caffeine extraction, and go into something else, or come up with a whole new paper or a whole new reply saying, no, it doesn't. What journals always do is they have a reply section, a letters section, where people can write in and say, I disagree with this paper because of the following experimental or theoretical or whatever mistakes they've made. Ethical issues also apply. So in the case of an online ResearchGate publication that isn't peer reviewed, there is no way to write back and say this is a terrible publication, apart from like this on YouTube, for example. If we look at some of those, we will see, so for example, the original Andrew Wakefield study on autism and vaccines. If you look that up, you'll see that not only has it been retracted, but there is a whole string of comments on the article saying, oh, they've done it wrong, and lots of reasons why. That is a key part of how science functions. It needs to have some way of future people writing in and saying this is bad information and getting it noted that it's bad information without actually changing the history of when it was put up. So you will probably also see, if you look up the original Wakefield vaccine article, that it is still there. So back to the paper, let's have a look and see what they've done. So first of all, we can see here that they called it a case history. Case history is handy because that's not normally a paper, so that's them being honest. They're saying it's a case study, a case history, which is just describing things that have happened. It's a medical term, or it's used in medicine to say, okay, this is a person who got this disease. It may or may not be statistically significant It may just be this one person and nobody else ever. That's why it's a case history. It's not. It's showing that it's not a statistically relevant study. So this is what they did. They took 50 symptomatic case reports, so people who had some kind of illness. Let me go back to this mode. So 50 people who had some kind of illness, and they were followed by the family doctor. So that means they had normal medical treatment and they also had homeopathic treatment. So remember that they had both medical treatment and alternative medical treatment. This shows that of those 50 patients, only 10 of them actually had coronavirus and were measured and shown to have it. The other 40 seemed to have it, but were never proven to, which is obviously not a very good way to carry out a study, because we don't know about 4/5 of our patients whether they actually had the virus that we're looking for or in fact had something else completely different. So here we can see that they do make some effort to show that the patients weren't given specific treatments against corona, although there aren't very many of those. That would be antiretroviral treatments. So they were given normal painkillers, normal treatment to reduce fever, and they were checked, and maybe lung treatment. So they weren't given specific antiviral medicine, Tamiflu, or antiretrovirus treatment, but they were treated generally, symptomatically effectively. So the standard treatment for flu or for corona, if you don't have it really badly, for people in the future was, for people in the present is, to do very little to try and reduce the symptoms so that you don't suffer any worse, but it doesn't actually attack the actual virus. There are treatments that can do that, but those are reasonably hazardous and quite expensive, and therefore are limited in how many people got those. This was done in Italy relatively early in the outbreak, so there wasn't enough treatment around. So I had a little trouble with this paragraph because I couldn't find the word biophenomenological really anywhere. I can find it in a few places, but it doesn't seem to make sense in this context, so I'm not entirely sure what's going on there. Something weird that should have been caught by an editor, but obviously there aren't any editors on ResearchGate. So these are the symptoms that the patients had to have to get into this study. The 40 patients out of 50 that weren't proven to have corona, so they had to have fever, weakness, dry cough and pharyngitis, or they could replace one of those symptoms, 1, 2 or 3, with chest pain. I'm not sure what that one is, conjunctivitis, which is which is irritation of the conjunctor on the eye, bone and muscle pain. But you can see that a lot of these are symptoms of a normal flu. So there is no way to tell whether the patients actually had flu or corona from these symptoms. So now we've established that there are 50 patients in the case study. We should see how many of those we would expect on average to get worse, so that we can see whether there are enough patients in the trial. So this is a paper 2019 or 2020 in The Lancet, a very good journal on medicine. And if we go down, whoops, mouse doesn't work. I have to use a different mouse. If we go down to the bottom, there's a handy table which tells us exactly that. So it's right down here. This is the table, it's in age, and you can see nobody below 10 was hospitalized. In China there were only 13 cases though, so it's not very statistically significant. Then 10 to 20, a very small proportion. As it goes up it gets more and more likely. So on average, if we stay below 50, it's around 5%, maybe slightly less, of patients that will be hospitalized. So at that rate, out of 50, we would expect maybe 2. But if it's lower, so if they're lower in age than that, then we would expect even less. So on average, it wouldn't be overly surprising if none of our patients actually went to hospital without any treatment whatsoever. And remember, they're all being treated by conventional treatment, however, no antivirals. So looking at the spread of our 50 patients in this study, 4 of them are in the age range where none of the patients in China were actually admitted to hospital. So that's not very worrying. So those aren't very important anyway. So the other patients were a range of ages up to, up to 79 years old. So none of them were in the high risk bracket. All of the rest were lower, and it doesn't say how they were distributed in that age range category, so it's very difficult for us to come up with an actual risk level. So we would expect maybe 1 or 2, maybe 3 of these patients would get relatively severe symptoms and would normally have been admitted to hospital, but this was a time when Italy was suffering fairly badly from overload, and so they probably wouldn't have been able to have been admitted to hospital. Most cases of corona survived anyway, with or without treatment, and 50 is just very low if we're looking at the death rate. At the time that this study was performed, the death rate from corona was estimated at somewhere between 0.4% and 1.4%, which would mean that it's highly unlikely that any of the patients would die with or without treatment, particularly considering that most of the casualties of this disease at the time were people of an older age range than any of the patients that they had in their group. To their credit, the authors are very honest in this bottom section in that they don't actually make any claims that homeopathy has treated these people properly. They also admit that there is no control group to show what would have happened if they weren't treated with homeopathy, which is obviously a major problem with this study. And they also talk about how the test didn't work very well for them because of the way that it was rolled out. But that is not because the test didn't work, it's because of the way that the politicians chose, or the way that politics chose, which people were tested and which people were not tested, meant that it was very difficult for this kind of test to be carried out properly, because you would have had to have taken all of your example people, tested them all, and then separated them into 2 groups, which you gave a real treatment and a placebo treatment. In this case, you gave conventional treatment plus homeopathy, probably not a 3rd group without conventional treatment, because that might be unethical. Then you would be able to get more information, and the group is far too small to get enough information here. Well, light's gone out. So to sum up, what is a scientific paper? A scientific paper will typically be peer-reviewed, otherwise it's not very scientific. People will have a right to reply, and it will contain honest, correct methods and materials, so instructions on how to exactly copy the things that were done. And in the future, it is often judged by people citing it, which means saying, oh, this is a good paper, I've read it, and using it for new things, which is important because it shows that there has been plenty of right to reply, that people have actually read it and made their own judgment about it and decided that it's okay. If you write a paper and it is not cited at all, then it's a bad sign, because it means that it has not gone through this proper feedback loop, and it hasn't been tested properly. The homeopathy paper has a lot of things that aren't that terrible. They were honest, they explained their methods reasonably clearly, they were very good methods, but they were honest about them. But it wasn't peer-reviewed, there is no right to reply, and it is only going to be cited by people that are like-minded, because the methods are not good enough that it tells us anything very useful, because the number of people and the severity of the illness was so low that the probability that anything would have happened is very low anyway, so it's not statistically significant. We can't tell anything. It doesn't tell us absolutely anything about the situation except for it's a nice story about what somebody did. So we can see that this homeopathy paper is okay. The authors haven't been actually fraudulent. They've been honest about what they did, but unfortunately, because of the small number of people that have been tested and the likely small effect of a new medicine, particularly considering they tried very different ones in 50 patients, because they tried so many different treatments and they would be expected to not have very strong effects, we are very unlikely to be able to see anything even if there was an effect. And so unfortunately, this paper is not going to tell us anything at all. That is an advantage of publishing in a normal journal with peer review, because the peer reviewers would have caught that and said, no, there isn't enough data here, this isn't enough information to tell us anything useful, and the paper would have been pulled out before it got published. Unfortunately, in this case, it's been published on an internet forum, on a database, without being peer reviewed, and therefore we can't tell anything from it. That's a pity. Anyway, hope that helps you to look at scientific papers in a different way. See you next time.